Hi folks, I welcome you back to Global Education Zone. And today in this episode of Physics for SSS3, we are going to be dealing with a subject known as magnetic field. So when we talk about magnetic field has to do with the part of physics that has to do with magnetic forces. So magnetic forces, they are forces that exist because of magnetic field, and this magnetic field, they have their properties. So this magnetic field, we can define them as the region of space around which an object exhibits or experiences a magnetic force. So what that means is that a magnetic field is a region of space where you can experience or exhibit a magnetic force. For example, like a magnet will exhibit a magnetic force around a region known as a magnetic field, whereas a piece of iron or any other paramagnetic substance can also experience a magnetic force around that same region. So next, let's talk about the concept of magnetic field. Now, I want to talk about the concept of magnetic field. The concept of magnetic field states that basically the concept of magnetic field it states that the area around the magnet in which it can attract or repel objects, or in which a magnetic force can be felt, is called a magnetic field of the magnet. So basically, that's what magnetic field is. So it's basically that region of space. It's kind of like an imaginary region, though. It's imaginary because it is the product of our imaginations. So we imagine that these forces exist. So they might not necessarily exist, but that is our imagination, and it works fine with science. So next, let's talk about the bar magnet. So you have your regions of space around the bar magnet. So this for example, this bar magnet we have here, we have it as it's a bar. Then we have two unlike poles. So basically, what this means is that a bar magnet is a piece of magnet, and it has poles. It has north and south poles, which is the parts that can repel or attract a particular object. For example, a north pole will attract a south pole, and a south pole will attract a north pole. It's kind of like a word and opposite attraction. So that is called the fact that unlike poles attract. So you can see in the second diagram, you can see the picture where you have unlike poles. So they are attracting together because of the force around unlike poles. So next, let's talk about the rules, the laws. There are some rules and laws guiding the behavior of magnets. For example, we have the first law, which says that, which one we've taken in this video, which is the right hand rule, which says that if a straight wire is grasped with the right hand so that the thumb points in the direction of the current, then the direction in which the fingers are curled indicates the direction of the magnetic field. So let me just explain that. It means that if you with your right hand, if a straight wire, if you grasp a straight wire with your right hand like this, so and you make sure your thumb is facing the direction of current. So if you know the direction of current and you make your thumb face that direction, that means your fingers will be curled in the direction of the magnetic force. So you can see that it's kind of like a perpendicular axis relationship. So that is how it works. That's the right hand rule. But that's not the only rule. We also have other rules. For example, we have the corkscrew rule, which says that when you are turning a right-handed corkscrew, the direction of motion of turning is basically the direction of motion of that magnetic field. So that is one rule for that. So we also have the solenoid. So this solenoid is basically an instrument that works based on magnetic field. So it's basically when you coil wires around a tube, or maybe like a cardboard tube. So it could be in a non-metallic tube. So, but once you have coils of wire, you can induce a magnetic field. So, and this is the basic principle on which an inductor is based on. An inductor is a special kind of electrical equipment that actually generates magnetic field from electrical force. So basically, when you have electricity flowing around those wires, so they will induce a magnetic field, and that magnetic field will turn that solenoid into a magnet. So this is the magnetic field of a solenoid. It can, when it is when charges are flowing in that solenoid, it can become attracting or repelling. So depending on the direction of the current flowing through the solenoid. So next, let's talk about the coils of current working in a solenoid. We have the north pole and the south pole. So basically, if you have your current flowing in from, let's say, if it is flowing in an anti-clockwise direction, that is from east to west. If it's flowing anti-clockwise, that means it is the north pole. Then if it's flowing clockwise, that's from west to east, it is the south pole. So that is depending on the direction of the solenoid that you are looking at. So and then this is a circuit. You have your rheostat. Your rheostat is a variable resistor. So if you've not heard of a resistor is basically an electrical component that offers a resistance to the flow of electricity, and it is very useful when you want to control electrical current. Then you have the battery, and this is a circuit, and when you pass that current through the solenoid, you will get an electric field. So it is a phenomenon that has been noticed with electricity for the past century or so. So basically, that induction effect, that an electrical field has the ability to induce a magnetic field if you turn it into coils of wire, and that is basically the principle that is also used in our rotor and many equipment like the induction coil, which we'll be talking about in a subsequent part of this series. So next, let's talk about your the single stroke and the double stroke method. So we have the single stroke method, which is from north to south. When you want to charge a magnetic, so you have the single pole method. So basically, these represent the two ways of charging a magnet. You have the single touch method. It's also known as the single stroke method. So basically, you just stroke from one pole to the other, and then you stroke with basically you stroke the magnet with a particular pole, and then the part you stroke from one pole. So from your starting end, it will acquire the same polarity as your stroking end. So but in the second case, your it's also the same thing basically, but in this case we're using double magnet. So in this case, your um starting pole still acquires the same polarity, but in this case it's only the polarity of the ends that matters, because the polarities at the middle, they cancel out. So that's one property of that. Then we also have the magnetic screening. So basically, this magnetic screening, it is the process of placing an iron sheet, a iron ring inside a solenoid. So in this case, this iron ring will absorb it will contain all the magnetic field lines, so that there will be no field lines in the space. So basically, it's kind of like a concentrator. It concentrates the magnetic field lines in the iron ring, and in this case, it makes the solenoid more powerful. So then we also have the electromagnet. So the electromagnet is an electrical device that basically works on the principle of this electromagnetic principle. So in this case, you are basically using a current to magnetize a bar magnet. So in this case, it relies on the principle that an electric field flowing through a coil of wire has the capacity to produce or induce magnetic fields and magnetic forces. So that's how you make an electromagnet, and it is useful. It is applied in major devices like the induction coil, in the speaker, in a lot of different amplifiers, and so on and so forth. So next, let's talk about the electric bell. So the electric bell is another device that works based on the electromagnetic principle. So in this case, you just complete a circuit, and then the electric field induces an electric force, and that rather it induces a magnetic force, and that magnetic force that is induced, it causes an attraction with an iron bell. So this iron bell will strike a gong, and that gong will sound. So that is how it works. So and then it also operates on the rapid switching of electricity. So basically, the electricity is switched on and off rapidly, so that causes the ringing effect. So this is one appliance that works majorly on electricity. You can also comment in the comment section if you have any other appliances that works based on the electromagnetic effect. But basically, that is what we'll be covering today in this video. Thanks for watching, and I hope you enjoyed this video.